Hi guys, I'm Tony Alden, and today we're going to see how to temporarily override function definitions. But before we start, if you get value from this video, give it a thumbs up and subscribe to the channel. So, what I propose to do today is, here you see that we have two functions, bar that take one argument and multiply it by 2, and foo that take one argument and apply that function bar. So it should return 2 times x. So we evaluate those functions. Here we will insert the result of the evaluation of foo with the argument 1, which should return 2. So we have it. So what we are going to do is to temporarily override bar, and we want to give it the value a body that take the x input and multiply it by 3, and we want to apply foo with the new definition of bar. So there are two ways of doing it. One which is with flet that we're going to see right now, and another that can be used, that can be done with advice add and advice remove. This can't be done with CFLET, but CLFLET allows to lexically, so we are going to see the difference between the FLET, which is dynamically, to lexically override bar. So in many cases this is what we want, and at the end we are going to play a little bit with let and lambda, and also the function funcall. So which this is something that often happens in package libraries. So this is interesting to see that, and to see why we when we use let and the macro lambda to with the function funcall, we are not really binding a function, defining a function, but something else. So let's go with flet. So flet, it's resemble a lot with let, but here we are going to pass first the name of the function we want to override, which is bar. Now we pass it the list of the arguments, so we have only one argument. Instead of multiplying by 2, we multiply by 3. So here in that part, now we can, if we call foo with the argument 1, bar is going to be bind to the new function that we defined, that take x and multiply it by 3. So we should get 3. So this is what we want. So here we've answered to the theme of this video. So you have this. If this is what you want to do in your code, you can stop the videos, or you can follow a little bit and see more tricks about Elif. One thing we want to be sure is that we've rebind foo, the function bar, in a temporary way. So we want here to get 2. So we evaluate and we insert in the buffer and we get 2. So this is what we wanted. We can check that bar give us 2 if we apply it with the argument 1. So this is what we add. So this kind of binding of the function is a dynamic binding because here in the scope, in this part, we don't see written the function bar. Okay, so this is a way that we can recognize what we are doing in a dynamic way or in a lexical way. So, okay, this is fine. Just one thing to mention with flet here, this macro is obsolete since Emacs 24.3. So maybe you don't want to use it in a library that you distribute, but it is. I think that it is absolutely fine to use it for your own usage or configuration, and you can find its definition in the directory obsolete of the Emacs repository. So let's see another solution that use advice add and advice remove, and those functions are not obsolete. So if you want to do something like that, we can use advice add and advice remove. So how we can do that? So we're starting with a let, and now we are going to define new bar, the new function. So we defined it with a lambda. We take x and we multiply x 3 here. So when the lambda function just return a list that we can see, we are just evaluated this thing, and you see at the bottom what it returned. So it returned that list with the lambda. So this is a function, and the let binding the new bar will let the value of the variable new bar with that lambda list, which is a function. Okay, perfect. So far we still haven't done nothing right now. We just defined the new bar. We want the result at some point, so we define that variable that is nil right now. And now here is the part that happens. So advice add, we maybe can look at the help buffer. So first it takes a symbol, so we are going to pass it the symbol bar, where is the way we want the advice to be applied, and the function is the new bar that we have defined. So it works like an add function, but for function name symbol, and we can look at function to see here the where part can be one of those one. Okay, so what we want us is to use the keyword override, because we want the function to be override with our new function. So let's go back here. So you can follow at the bottom also. So we symbol, we pass it the symbol bar, because this is the one we want to replace. Here we want override, so we pass override, and we pass the name of the function. So we pass it new bar. So here, as it is a function, yes, so this is a function. The argument there are going to be evaluated before they are passed to advice add, and so new bar here will be replaced by the list lambda x blah blah blah, which is a function. So here now we should have the function bar modified and override. We bind the symbol res with foo applied to 1, and here we want res for result to be bind to 3, because here we should have bar rebind with new bar that is defined here, and that multiplies 3 with the input. But we should remember that what we want to do in this video is not only to override a definition, but to do it temporary. So now what we can do is to remove the advice. So here we have the advice, and we just have to pass it the symbol on the function that we add before to that symbol. And now here we return result. On result, we remember this is the value of foo1. So if we evaluate this form and we insert the result, we want to have the result 3. Oh, okay, great. This is another way to do it, but we still have to verify that we've done it temporarily. Okay, it seems that it's good. Bar 1, and we should also have 2. Okay, so this is working. We've seen 2 ways to temporarily override function definition, and that works dynamically, which means that the function bar that is used in foo that we don't see here, you can see in this piece of code we don't see the bar used, but it is used with an override function. So now, why I insist with that is because if we use clet, this won't work. So we can copy this one, and instead of flet we put cflet, and this is make local function definition. And because I told you before, this won't work, so we should see 2. We might think, but clflet told me that when I'm writing this, I'm really defining to the symbol bar the function that takes x and multiplied by 3. Yes, this is true, but in a lexical way. So to see it, we need here in the body, after the binding, to see the function, the name of the function used. So now, if we use bar, we apply bar with 1 with the new definition of bar with the macro clflet, this will return 3. Okay, this has changed, and we can see here that this has been done locally, temporary and locally. Here it's returned 2. Okay, so to have the differences, this has not the same the same function. clflet do the binding, the overriding locally with lexical binding, and the other with the dynamic binding. So now this one is I was going to say funny. I don't know if it's funny, but it's a really interesting one to look at, and we are not going to we don't try to make it work because it won't work with the thing that we want to do. So that means we can't bind bar, use foo with bar with the new binding, but it's better to do something, less words and less talk, and do the thing. So here, maybe I want to do something like that. I think that why can't I do that? Lambda x, and I multiply x by 3, because here I'm binding bar, a variable, with something that is a function. Yes, so we look at this. I tried not to give the answer, but I think I'm giving the answer anyway. But bind variable according to var list. So what we are we do there is that we are binding the value of the symbol. So this is why we won't see the thing working as we might think. So let's just try foo. So we might think that it works if this is the first time that we use it, or we misunderstand let. and it doesn't work. But in fact, this is absolutely normal. And we might think, okay, so just 1 second, I have to think the order. I want to show you the thing to make it more interesting. So now I want to show you okay, so let's try bar, and this won't work. See, okay, this is what I wanted to show you. Sorry for the blank. So now we think, imagine we quite don't understand how the let work, and we think that we bind bar to that function, and we get as output 2. And we say, I don't understand why this is happening, because I've binded to a function, but not exactly. But now, if you have already read some Emacs library, you might have encountered this use like this. Okay, so you have here in a let binding a variable bind to a lambda list, which is a function, and then this is used with funcall. So we can see funcall is just here. So you have the name of the function and then the argument, calls the first argument as a function, passing remaining arguments to it. Okay, and you see that, and we get 3. And you say, okay, what do I am missing right now? So the thing is, and we are going to see it right now, is that when we pass here bar to the function funcall, first bar is as a variable, return is evaluated and return its value, and its value is that list, which is a lambda function. So funcall will call it, that function here, with 1. This is what we get. But in fact, we haven't defined a new function, because, and we can see that here. So maybe we will do that to have a little bit more space. So what we can do now is to look at the symbol value. Okay, so if we look at the symbol value of bar, because this is maybe something that we want to look at. So symbol value, we've seen it in the last videos. So if you want to see, but we return symbol value, error if it this is void, of a symbol. So this return the value of the variable bar here, and here we should see something like that function. So what does that mean? That means that the symbol bar as a variable has the value that list, and so when we evaluate, when we get the value of that variable, this is that list, and we can use it as a function, and this is what we did here. Okay. If we go a little bit further, and now we want to look at function, so we can do this symbol bar, and we want to look at the cell function. Okay, so here we see it, return symbol function definition of nil if that is void. So what's happening is that bar as a symbol, the symbol bar as a function is defined with the function that we've defined at the beginning. And we can see that right now we evaluate, and so the binding, the let binding of bar with time 3 time x doesn't appear, and you see there we have the 2, because this is what we have at the beginning. So as a function, the symbol bar is defined with that function that take x and return x times 2. And the last thing I wanted to show you, so I hope you find this, if it's not useful, at least interesting. And if we do that, so we can do and bound p test if something is a variable. So return 2 if symbol value is not void, so it means that the symbol is a variable, so we pass it bar. And function p, and this one return 2 if the object that we pass it is a function. And so the symbol bar right now, when inside the let binding, is can see as a variable with the definition that we have here, or as a function with the definition as we have here. So if we evaluate this form, we should get true. Okay, so this is what I wanted to share with you today. I hope you find it useful, and have a great day. See you next time.